Hi everyone, let's begin ANCOVA. We would understand what is the difference between ANOVA and ANCOVA. So first of all, ANOVA I had already explained you. That is ANCOVA is basically an extension of an ANOVA. ANOVA we have not taken any covariance, but in this study ANCOVA there is covariance is also existing, and that covariance that is mandatory that would be at the continuous variable. So, first of all, how we have to go through all the assumptions of ANCOVA. So, ANCOVA, it is an extension of ANOVA in which we would like to determine if there is a statistically significant difference between three or more independent groups after accounting for one or more covariates. So there are some assumptions. I had already said covariate is a continuous variable that co-varies with the response variable. Means we have taken at the ratio scale. So assumptions one by one. Number one is covariate and the factor variables are independent. We have taken in our study one factor variable and one covariate, and both are independent. And the covariates are continuous data. The covariate should be continuous. That is, either it could be measured at the interval scale or ratio scale. So I have taken in my study at the ratio scale. Homogeneity of variance means the variance among the groups should be roughly equal. So all groups have equal variance. In my study, we have to check. In my case, and independence, there's the observations in each group should be independent. And last one is the normality. The data should be roughly normally distributed in each group and no extreme outliers. We have to check through box plot outliers also. If there is any presence of any outlier, we are going to remove this. So there should be no extreme outliers in any of the group that can significantly affect the result. So we will take this example, similar example. I have used the same example in my ANOVA video when I had recorded this video. Whereas an MBA aspirant was interested in knowing the impact of educational background. There are two categories of educational backgrounds, arts and commerce and science and engineering. On the final placement salary, that is giving impact on the final placement salaries. He is also aware that previous work experience has an impact on the salaries. So therefore, he chooses educational background and work experience as two independent variables. Right. So based on the educational background, respondents are categorized into two groups. One belongs to arts and commerce stream, another one belongs to science and engineering stream. That is entirely categorical data. So means there's the one, means that one is the one factor that is categorical. A sample of 30 students is randomly chosen, and their salaries from campus recruitment as well as information on educational background and work experience. For educational background, one represents arts and commerce and two represent science and engineering. And for the work experience, we will talk about educational background, and this one is the work experience measured at the ratio scale, and salary is given the multiple of the lakhs. So students, total number of students are 30. After that, you can see educational background, 1 and 2 we have taken. Then further it is work experience. Now you could see work experience is there, and there is the salary. The same file we are going to use. This one is the hypothesis also. The educational background has no impact on the placement salaries of the MBA. MBA students from science stream will get more salaries during the final placement and so on. So further we will go to this Jamovi, and we will open a new file and I can browse it. And this is my ANCOVA file where is the same data, it is saved. And you could see in the first column students, that is only number. So this is the nominal data, right? And second column educational background, that is again categorical data. So this one is the nominal again, arts, and this one is the we can say talk about the arts, and this one is the commerce background, and these are the science background, etc., right? And work experience and salary, etc., we have taken into our consideration. So this one is the, let me just I'm changing this data because this is the data that is the old data, and I'm just pasting this, right, hours and I'm just saving this data and we save this, right? And that we will save this after this. And what we have to do, let's say, this is the hypothetical data. So first of all, we are going to check descriptives. And descriptives, let me take work experience and salary. What is the maximum value, mean value? Now you could see mean value 1.67 for the work experience and the highest number, lowest number, right? And salary is also 3.20 and maximum salary is 11 lakh. And further is, let's say, educational background also, frequency we want to check. Frequency that we can check only categorical data. Educational background, now you can see arts and commerce, total count is 18 and science background, total count is 12. Right. So in that way, that is reflecting. And further, what we have to do, we will go to, this one is the, we will go to ANOVA and sorry, ANCOVA. And further is ANCOVA, this is my salary is my dependent variable because salary depends upon work experience is my covariate and educational background is my fixed factor. That is categorical. A moment we had put it all those things, now you can see work experience that is significant, means that is impacting on the salaries. Right. And educational background that is 0.116. That means educational background that is null hypothesis, that is not giving any impact on salaries, final placement salaries. Right. So overall model test also you can check, and overall model test that is also significant. That is, we can say overall model 0.001. Yes, of course, that is p-value is less than 0.05. That means that is giving impact. And further is, we will go to, this one is the partial test square, right? Partial test square, now you can say, what is the explanation? So 58% explained by this work experience and 0.08% by educational background, right? Eta square and partial eta square, you can check. This one is the 56% and 0.03. And further is, we will go to interaction effect. Yes, interaction effect. Suppose we are going to select both these things and this one is the interaction. We will select now interaction effect. So overall, we can say, what about educational background and work experience together? How it is impacting, right? So here's the p-value that is 0.49. So that means null hypothesis is accepted, fail to reject here. And educational background and work experience is, right, there is together, they are not impacting salaries. Further, we will go to assumptions check, right? That we have to do in the beginning, right? Homogeneity test and homogeneity test, what is saying? Homogeneity test 0.209. And yes, of course, these are the, I had already explained here in the homogeneity test. Group have, here it is, all groups have equal variance. All groups have equal variance. So because null hypothesis, that is the value, it is greater than 0.05. So that is, we can say all groups have equal variance. Normality test also we can do it. And normality test, Shapiro-Wilk test is 0.438. So that means we can say our data is normally distributed, right? And further we will go to QQ plot. And in QQ plot, that is also, we can say our data is normally distributed. Then we go to, this one is, let's say, let me go back to, this one is descriptives. And when we will go to descriptives, then we have to check our bar plots also. So whether there is any outlier, because this one is assumption also we have to check. This assumption, no extreme outlier should be there. Normality we have already checked. Right, independence already we have already gone through, homogeneity of experience, covariate, and all these things we have checked. And now what we have to do, we will go to plots and box plot, right? So this one is the work experience box plot. Now you can see work experience box plot. Now what is happening here? 18 number is our outlier, and that is the extreme outlier. So we should remove this, right? And salary doesn't have any outlier. So what we have to do, we will clean our data. Right, we will go back to our data and 18 number entry, this is my entry. So let me delete this entry, right? Further delete this row, right? Okay. So now we can see there is no outlier, right? Further, we will go to analysis, and what we have to do, we have to run again ANCOVA, and now we will check educational salary is my dependent variable, work experience is my fixed factor, sorry, work experience is my covariates, and educational background is the fixed factor. Now you can see when I was trying work experience to shift is there, but it was not considering. Why? Because there's the symbol you can see, there is the, it should be nominal data, right? It should be a categorical data. That is why we could not be able to. So now overall model, you can see overall model, that is again same p value that is greater than 0.05, the same interpretation we have to give, and eta square partial eta, right? So we have to check 53% is explained by work experience, educational background 0.3% only explained by this work experience. Then further we will go for interaction effect, and interaction effect, now we can see interaction effect, that is the p value 0.731. So now we can say jointly p value that is not impacting on the salaries. And homogeneity test, yes, of course, 0.425, that means equal variance. And further is normality test, right? Normality test. Now Shapiro-Wilks, now after removing this, now you can say our data is on the margin, right? And further we will go to QQ plot also. Now you can see, now you can see this is not reflecting your data is exactly normally distributed. That is the same interpretation is our here. And further it is the post-hoc test, and we will go for the post-hoc test and educational background, right? We have to post-hoc test, it will tell you one by one with each and every group what is the comparison study we have to give this educational background, right? There's the arts and commerce and science, they are the two. This one is the p Tukey is the 0.219. And further is this the Bonferroni, and I will make a independent video on this Bonferroni. And let me just give you what is actually where we are going to use Bonferroni. And Bonferroni, I will make a next video would be on my Bonferroni, and then you have to just see what is this and where we are using and how we are going to apply. So Bonferroni post-hoc test is a statistical method utilized to make multiple comparisons between group means following the discovery of a significant overall effect. It specifically assesses the significance of mean difference such as those between the scores of first year students and second year MBA students, right? So that will give you, that is the post-hoc, that is the correction. Actually Bonferroni is the correction, statistical correction, that will give you multiple comparisons between the groups, and that will give you actually how we have to correct it, right? So we will discuss in my next video how we are going to apply this, and I'm sure this video would be helpful to you. So stay tuned and keep watching, and thank you.